This is today's homework. We did this in class. We did number 3 in class. So number 4, 8, and 9. Misnumbered them, sorry. Joe and Danny went to put up a custom-made round, start over. Joe and Danny want to put a custom-made round table in their dining room. The tabletop is made out of glass with a diameter of this long. Okay, a diameter. Remember a diameter? That's a diameter. Call a hypotenuse also. Slanted line. That's a diameter of 85 inch. The front door is 36-inch wide. Okay, 36-inch wide and 80-inch tall. Joe thinks that the table will fit through the door, but Danny does not. Who is correct and why? Okay, so that is the table with that diameter. We want to see if the table is that big, will it fit into there? This is for the table, okay? We don't, so I'm going to erase diameter. I read it. So we want to know if this diameter will fit 85 inches. We're not sure. Okay? So we'll see how big that diameter is. Needs to be bigger than 85 for the table to fit through. A squared plus b squared equals to c squared, so you get 36 inches plus 80 inches squared equals to the diameter squared. Okay, 36 times 36 is calculator. Where's the calculator? Oh, right here it is. 36 times. That's 1296 plus 80 squared, 6400 equals to d squared. You add them together. Get 7696 equals to d squared. Take the square root, take the square root. D equals, you take the square root of that, it's 87. Let me just make sure. 7, 6, hold on, square root of 696. Yep. Get 87.73. The reason why it's 3, because that's a 6, that turns into a 3. So this can fit up to 87, the diagonal, 0.2, something as big as that. So therefore, the door is only 85. 85 is about right there, so the door can fit in. Let's see who's right. Joe thinks that the table will fit through, and Danny does not. Therefore, Joel is correct because the door can fit up to 87.72 inches, and the table is smaller because it's 85 inches. And the table is smaller because it's only 85 inches. The other one's 80, the doorway's 87 and the table's 85. It can fit through. Okay, Anthony has a 10-foot ladder, which he's placed 4 feet from the edge of the building. So some class I went over this. So a 10-foot ladder, a ladder is leaning, and he's placed 4 feet from the edge of a building. So that's 4 feet. Here's the building. And that's 10 foot. Will the ladder reach 9.5 feet? So will it go up to 9.5 feet? Let's see. If it's more, it's okay. To go higher, you can always stop. So in class, I do show a picture of a ladder. So in class, I did Google ladder, or in one of my class anyways. Not a good one, climbing ladders. Okay, so where the ladder is leaning. See, the ladder's leaning. The ladder's leaning, so it creates a 90-degree angle. Climbing up a ladder that's 98, making it the ground a 90. Let me see a better one. This one, if you imagine this to be a building here, that would work. Where is there a building? Goodness gracious. This one. This one's a good one. The man is, the ladder is leaning, the wall is straight, the ground to it is 90 degrees. Hoping that kids can see it better. So that the ladder is C. Okay, and A squared plus B squared equals to C squared. So 10 squared equals to 4 squared plus B squared. 16 and 100, B squared, subtract 16, you get 84, B squared equals to 84. Take that square root, the square root of 84. Is 9. B is 9.17. So the ladder, B, we'll put ladder. No, we're not finding the ladder. We're finding the building. How high can it reach? So we'll change B to R so we know how high the ladder will reach. Here's the word reach right there. We want it 9.5 or higher. So I'm going to change all. I should have used a different color. Okay, change to B to R because we were trying to see. Okay, the ladder can reach up to 9.1 and the building is 9.5. No, the ladder will not reach 9.5 feet. The ladder cannot reach 9.5 feet, only up to 9 point, if you want to round it to the nearest tenth, 2 feet. It means whoever use that ladder, try to reach, may fall down and hurt themselves. It doesn't reach high enough. Okay, here's this one. Nestor walked to school every day. He must travel 4 blocks east. Oh, name change. It should be Tanya. Tanya walks to school every day. She travels, she must travel 4 blocks east. So it goes 4 blocks east this way. And 3 blocks south this way. Around the parking lot. Upon arriving to school, she realized that she forgot her math homework. In a panic, she decides to run back home to get her homework by taking the shortcut through the parking lot. This should say Nestor. Oh my gosh. Okay, I need to remember to change that. Describe how many blocks long Nestor shortcut is. So we're finding this one right here. So change Tanya to Nestor. That will make it easier, and then we don't have to change all this. Describe how many blocks long Nestor's shortcut is. You do 4a squared plus b squared equals c squared. Four squared plus 3 squared equals to c's shortcut equals to the shortcut. We'll put s squared. Okay, that's 16 plus 9 squared equals to the shortcut squared. Well, not 9 squared equals to 9. 25 equals to the shortcut squared. Take the square root. The shortcut is only 5 blocks. Okay. How many fewer blocks did Nestor walk by taking the shortcut? Well, the shortcut's only 5 blocks. The normal path is 7. 4 plus 3 is 7, is the normal. So 7 minus 5 is how many fewer blocks? 2 fewer blocks. Okay. Matthew is helping his dad to decide how many of the tiny tiles he can buy to put around the swimming pool. Company West charge $150 setup fee, and means plus, fee is plus, $2 per tile, T for the number of tiles. Write an equation is equal to the total cost, C for cost, that Matthew buys for the title. So 150 plus $2 per tile, 2 times the number of tiles, equation is equal to the total cost, C. Alright, so T then is the number of tiles that he's going to buy, and C equals to the cost, or total cost. Okay? How many tiles can Matthew buy if his dad gave him $650? So $650 is cost in dollar. So you put where the dollar is, right there. 150 plus 2t equals to 650, and you solve that. Minus 150 minus 150, 2t equals to 500, so t equals to 250. He can buy 250 tiles. How many tiles can Matthew buy? Matthew can buy okay, and that's it. That was homework.